Page 179 says check the data below for normality. Creating a display histogram, dot plot, or stem plot. Okay, so these are not ordered pairs. This is just raw data. We don't have X and Y value, correct? So we're going to jump on to Desmos. And plug the data on in. Let's see. So we got to make ourselves a table. Just use the X value. So 3, 1, 1, 5, 0, 1, 2, 2, 1, 0, 2, 1, 3, 0, 1, 2, 0, 4, 1, and 2. All right. So it says goals scored each game for an entire soccer season. Okay. So first thing we can do is we can just type in, we can just do histogram of X1. And 1, 2, 3, there's six plots to that. So that histogram's fine. I mean, you could maybe change it like to 2. Nah, go back to 1. Okay, so looking at that, it appears that it might be a little bit skew right. So it might not be totally normal. But then what we can also do is we could do a box plot of X1. And so by turning the histogram off, so that's right there, definitely that verified our conclusion. It is not a normal distribution. Our box plot, we only have a singleton center box. So this is not a normal, this doesn't have normality to this distribution. Okay, so that's the first thing we do. All right, so let's get rid of all these. Get rid of those. So the second problem says the lifespan of golden retrievers in years. Okay, so we got 16, 22, 20, 16, 13, 15, 16, 16, 14, 12, 17, 14, 15, 17, 16 and 15, and 15 and 16. So take a look at our histogram. So there's our histogram. We got plenty of stuff that appears that it's kind of skew right, but it also appears it could be kind of normal distribution. So let's see where our box plot will fit with this. Our next one, right? Yep, next one. No, hang on. So if we take a look at the dot plot below, oops, turn you off. So again, we only have the single box that's showing up. We don't have the two rectangles there. So I don't think that is relatively normal either. But remember, if it's normal, not a normal distribution, doesn't mean we can't use it. It's just that, you know, we can't claim that it's normal. So if we said, hey, we have a distribution, we're trying to figure out data off of, if we say it's just a distribution, then that tells the reader that it's not that's not that. So let's take a look at the next one. Oops. Get rid of this. All right, then we have time it takes for people to complete an online crossword in minutes. So we got 32. Connor, do you have a question?
Yeah. What would make it look normal?
The box plot would be symmetric. The two rectangles in it would be the same size, and the tails would be the same size. for the most part, as well as the distribution would look like it would make a nice rounded curve. Okay.
What would make a what's it called, histogram look normal?
It would look like if I drew a curve around it, it would look like it forms that nice normal curve. Yeah. All right, 42, 41, 24, 37, 52, 19, 36, 51, 39, 44, 46, 39, 29, 61, 50, 45, 44, 30, and 39. All right, so let's take a look at our histogram. Ooh, that's too many bars. Let's make it maybe 2 width. Nope, 3 width. Maybe 4 width. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That works. All right, so this appears to be somewhat of a normal distribution. Let's take a look at our box plot. Our box plot. The nice thing on our box plot, this is pretty close to normal, where these two rectangles are the same size. This length here and this length here are approximately the same. So I'd say, even though our histogram looks like it's missing a couple cells to it, I'd say it's pretty close to a normal distribution. I mean, we might be able to play around with this to make it look a little nicer. 6. Yeah, that one actually looks pretty good. So that's pretty close to a normal distribution as far as this. And it says, Jeremy, number 4 says, Jeremy, we don't need to make charts. All we have to do is calculate the mean and the median. If they're equal, that means that the data is normal. Is Jeremy right? Jeremy is partially correct. Jeremy's partially correct on that. A couple other things that we could have looked at with these. We could have, let's see, let's find it. It's functions, statistics. We could have done the mean of x1. Mean of x1. And then we also could have done the median. Mean and median. Sorry, I'm going backwards in my head. So this is pretty close. I mean, right there it tells us of that particular one, our median is 40, our mean is 39.85. Those are pretty darn close. So when Jeremy says all we need is the mean and median could also be the same, but you could have some outliers that are kind of balancing things out. So, you need a little bit more than the mean and median. All right, back side of the page. Says each of the following is a 5-number summary for the data set. Sketch the box plot with labels. Does this box plot give evidence of a normal distribution? Why or why not? Okay, so first thing, 5-number summary is not something that we can use on Desmos. We have to just draw it out the best we can. So if I have 0 here, this goes all the way out to 50 here. And then let's see, 10, 20, 30, 40. No, let's undo those. 10, 20, 30. 0. Yeah.
How do you adjust the amount of bars on a histogram?
Comma 1, comma 2, comma 3.
Huh?
Your y-axis.
So you change once you have the histogram plugged in. See, I made this histogram width 6.
Right.
So you just change that number until it becomes visually appealing, where you have 5, 6, 7, 8, 9, or 10.
Yeah. All right. Thank you.
Yep. All right. So this is our data for problem number 5. Okay, we have 0, Then we have 20. Then we have 25, which will be here. Let's pretend I can draw really well. Then we got 30. Okay, and then we have 50. So this is my box and whiskers. So each of these widths are the same. Those are both 5 and 5. That's great. This is 20 and this is 20 as well. Those are great. So this appears that it would be a normal distribution. So that's a good amount of test right now. If that was the only thing you had to use or the only thing provided, you could say it appears to be a normal distribution based on this situation, because that box plot, even though I can't draw really well, is there. But we don't know where the mean is. You know, the mean could be close. I'd say the mean would have to be about 25 as well, because it does look symmetric about itself. So those are a few things. Number 6, we got 10 to 60, 30, 40, 50, 60. All right, so this goes from 10, and then we got 15, that's here. We got 25, that's here. And then we have 40, which is here. And then we have 60 after there. All right, so this has a span of about 5. This has a span of 10. And then we go, that's a span of 15. And then the last span is 20. This is not normal. It's not normal because these don't match and these don't match as far as numbers go. So that would not be a normal distribution. And then 10, 20, 30, 40, 50. So number 7, you got 10 here, 20, 30, 40, 50, where you have this. That appears to be a very symmetric situation. Boxes are the same. So this could be normal. Okay, but we still need more. And then create a display that is not uniform. I wouldn't worry about number 8. That seems like too much hard work. All right. Let's go to our notes to 3-3. I don't know what page that is. My book's different than your book, so I can tell you my book page, but your book page will be different. All right. So this is the normal curve that we go to look at. These values are only approximate. They call this mu. This is the mean. It's also the median. 71. Thank you. And then within 1 standard deviation, here. So they're going, plus 1 standard deviation. Then you have another one plus 2 standard deviation, plus 3 standard deviation. And then we're minusing it, minus the standard deviation. That's not in a 6. That's supposed to be a Greek letter phi. Minus 2 standard deviations, and then minus 3 standard deviations. All right, so this first green region here, you have 34% on either side. You add 34 and 34, you get 68%. So roughly 68% of your data should fall within 1 standard deviation. That's either above or below the mean. Okay? So notice, again, they're using the word about. So if you actually went and looked truly what this was, you're going to get like 67.96, or you might get 68.03. I mean, it's right about 68, but for our purposes right now, we're good to go. If I were to include these regions out a little bit further, this is 13.5% of the area, as well as 13.5%. So if I were to go within 2 standard deviations of our average, we were talking about 95%, roughly 95% of our data. And then if we go a little bit further out, this is an area of 2.35%, and this is an area of 2.35%. So if I were to go out one further standard deviation, this gets us to about 99.7%. And then the last 0.15 of the area is way out here. So this is 0.15%, and over here is 0.15%, which you're talking about an extraordinarily small amount. Okay, so they say that 68% of the data lies within one standard deviation. So 68% of our data falls in this area. This is 68% of the area under the curve. If I go a little bit further out, if you add 13.5, 34, 34, 13.5, you come up to 95%. And then if I go 2.35, 13.5, 34, 34, 13.3, or 2.35, you get to 99.7. Again, those are approximates, but it's good to use that for just our foundation. All right, so anything important there? All right. So according to the properties, normal distribution, 68% of the observations should lie within one standard deviation of the mean. What if our data, 80% of the observations lie within one standard deviation? This would be pretty strong evidence that our data is not represented in a normal distribution. So if our figures don't add up to how it is, that right there tells you that we're not following with normalcy. And then let's take a look at some examples. Okay, so they have these test scores that are listed. We could list this in the calculator, and this is telling us that from our data above, 69.8 is our mean, and our standard deviation is 13.6, so you'd add 13.6 or subtract 13.6 to get within that. So we're talking about data that falls between 56.12 and 83.4. 68% of our data should fall within there. Okay, so if we count this up, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 30 pieces of data, and they said, so they're saying that 68% of those scores above, if this is normal distribution, should go between 56.2 and 83.4. They found that 18 out of 30 of the scores, so they went back up here and figured out which of these scores didn't fall within that. So 18 divided by 30 is 60. 60 is not 68. I mean, you're 8 percentage points away. So if you were to look at this, if we were to go the 95% rule, that means that if I go 2 standard deviations out, so between 42.6 and 97, we should be talking about 95% of the data should fall within that. And if we do this, we're going to find 29 out of the 30 scores fall within 2 standard deviation, which in this case is going to be 97%. So again, that's 2% away. So basically what they're doing is they're looking at the normal distribution, and they're saying, hey, do I have 68% of my data that falls within one standard deviation, or do I have 95%? So what you're basically doing is you're taking your data. So the first situation, we had 18 out of 30 scores that fell within that, which gave us 60%. And then if I went out a second standard deviation to go a little bit further, that's 29 out of 30 pieces of data fell within that, which is 97%. Well, this 97%, that's 2 away from that. The 60, that's 8% away from that. So this technically is not a normal distribution. It is a distribution. It just might not, it doesn't fall under our categories with that. So now we've added a little bit more to our wheelhouse of how to check for normalcy. So far with normalcy, mean and median. If they're the same, good, check box number 1. If my distribution appears to be normal when I'm looking at it, and then I look at my box plot, and my rectangles are the same size, and my tails are the same size, that's also normal. And then the next test that we go into is basically checking to see if our data falls in. If these 3 pass the test, then if I came out a third standard deviation, if you got to 99.7% of your data fell within there, these are all tests to check for normalcy. So there's definitely some characteristics. If someone said you got a normal distribution and all those tests don't pass, that's just a big way for you to say, no, hello, I see it. And this is where you can start catching if things are being truthful or not. Okay? There's all kinds of dishonesties out there. Heck, we just went through an election about a little less than a week ago. Okay, there was all kinds of predictions. Oh, this person's going to do, this person's going to do, this person's going to do. And what's up with Arizona and Nevada being the last ones to get their votes counted?
They're always the last.
Yeah, I don't know what's wrong with Arizona. Maybe it's too hot down there. Nevada, they're just too scarce. I kid you not. Do you guys know that the state of Nevada, and someone could call me on this, it was something like 95% of all of the land owned in the state of Nevada is owned by the federal government. Something like that. Someone check that for me, but it's pretty high percent. Let's ask Siri. Siri, what percent of Nevada is owned by the federal government? Over 80%. I was off. But my exaggerations are good. So, all right. All right. So, in addition to, okay, so finishing up this, are we good enough to say this data represents normal distribution? Becomes a judgment call. Just be honest when you are, presenting stuff. If people are holding back information because they want you to buy into what they're saying, big question mark there. Okay. In addition, the mean is 69.8 and the median is 74. So all of a sudden we go from a mean of 69.8 to a median of 74, which means we're skew left. Final verdict, this data set does not represent a normal distribution. So all of the things on Desmos, you can do the histogram. You can plot your single data. You can find a box plot. You can find the mean. You can find the median. Okay? There's all kinds of stuff there. Heck, you can even say, I want the standard STD, standard DEV of X1. I can find the standard deviation of it. Yeah. If you go up the steps to the right, it'll be a better perception. So all of that information can be given to you on Desmos. It'll do it for you, which is pretty cool. I mean, I think Desmos is a pretty powerful tool for you. So I want to give you guys the opportunity to start on the stuff. So is that 3 we did? 3-3. So 3-3 will be your assignment, whatever page that might be, 170 something, maybe 180.